All right, let's jump into it. Today we're going to be taking a deep dive into AI that can actually talk back to us. Not just understand what we're saying, but actually have a real-time conversation.
It's really changing how we're thinking about interacting with large language models. We're not typing anymore. We're talking about this seamless speech interaction. And this paper from the Chinese Academy of Sciences, LLaMA-Omni, that's what it's all about.
You know, I love to really dig into the research, but this idea of open source really caught my eye.
Yeah.
Like, we always hear about all the big companies, but LLaMA-Omni is built on this model, LLaMA, so anybody can use this technology.
Yeah, it's exciting. It's not just about how the tech is developing, but also who gets to use it. And the way they did this whole speech interaction thing is really clever.
So how does it work? How do we go from speech to speech? I just imagine a ton of ones and zeros. Explain it like I have no idea what's going on.
Imagine this, like a relay race happening in the AI's brain. First, your voice goes to the speech encoder. That's the runner who takes the sound and turns it into a basic message.
So it takes what I'm saying and makes it so the AI can understand me. Then what?
So that simplified message goes to the speech adapter, and it gets it ready for the LLM. The LLM is like the star athlete, you know? It figures out what's going on and comes up with the response. That's still in text, though.
So we're going from me talking to this text message in the AI's head. How do we go from the text back to sound?
Well, at the same time, and this is really important, this speech decoder is changing that text into sounds. It's kind of like giving a musician notes to play. And then the vocoder, that's like the instrument itself, takes those notes and makes the actual sound you hear.
Hold on. So while the LLM is figuring out what to say, the sound is already being made at the same time. No wonder it can respond so fast. I mean, 226 milliseconds, that's crazy fast.
Exactly. That's a big reason why LLaMA-Omni is so efficient. But training it, well, that was tricky. Most of the data sets are only text, not conversations.
So how do you teach AI to talk like a person? If it only knows how to read and write, that's got to be tough.
Yeah, it was a challenge. They made their own data set called Instruct S2S 200K. First, they took those text instructions and made them more like speech.
Speechified? What does that even mean? Do they, like, pay people to add a bunch of like and everywhere?
That's a funny thought. It was more about adding those little words we use when we talk, making numbers sound right when you say them, and just making it sound like a real person talking.
Okay, so now the AI can understand us. But what about teaching it to talk back? How'd they get it to sound natural, not like a robot reading a script?
They used another LLM to make responses that sound concise, like you'd say in a conversation. And get this, they used some really good text-to-speech to make the audio for both sides of the conversation.
So they basically built a whole world where the AI could learn how to understand and talk like a real person. That's pretty smart. But did it actually work? Did LLaMA-Omni pass the test?
Well, now things get interesting, and I think you're going to like what they found. They compared LLaMA-Omni to all the other big speech language models out there.
Okay, tell me everything. How to do against the competition.
So they took LLaMA-Omni and put it up against things like Speech GPT, SAML, and then even Qwen 2 Audio, and it did really well.
Really? That's a pretty big statement to make. What were they testing? How do you even judge a conversation with AI?
They looked at everything, like how well did it follow instructions? Did the speech sound natural? And they used humans to judge it, but also, get this, another AI, GPT-4.
Wait, so they're using AI to judge other AI? That's kind of wild. But I guess it makes sense if you want to see if something sounds natural or makes sense. An AI that's really good at language would be the best judge.
Exactly. So GPT-4 was looking at whether the responses were right, short and sweet, and sounded like a person talking. No robot voices allowed.
So it wasn't just about the words, but how it said them.
Yeah.
I bet that's where that speechified data they used really helped. But what about the actual speech? How good did it sound?
They had a few ways to check that. One was this thing called word error rate, or WER. It basically tells you how much the spoken words match the text.
So it's like spell check, but for talking. A lower we means the AI is saying what it means, which is really important if you want to trust it.
You got it. And LLaMA-Omni had the lowest WER. It makes sense because the text and speech are being made at the same time, so there are fewer mistakes.
Makes sense. So LLaMA-Omni can understand you, it talks back naturally, and it says what it means to say. Not bad, but you mentioned how fast it was before. Was it really as fast as they said?
Oh yeah, it was fast. They measured this thing called response latency, basically how long it takes for the AI to start talking after you stop. And LLaMA-Omni was super fast.
Okay, so how fast are we talking? Give me the numbers.
For just text, it only took like 1.49 seconds on average. But even for talking back and forth, it was only 1.92 seconds.
Less than 2 seconds. That's basically instant. I can see why this is a big deal. It's like talking to a real person, none of that weird waiting around like with some other voice assistants.
Exactly. And remember, it's still accurate and sounds good and doesn't make many mistakes. But there is a trade-off, you know? It's about finding a good balance.
There's always a catch, right? What's the trade-off?
Well, it's about the size of the chunks of sound we talked about before. Remember, the speech is made from these little chunks of audio. The bigger the chunk, the smoother it sounds, but it takes longer.
So it's like, do you want a quick answer that's a little rough around the edges, or do you want something perfect that takes longer, like a rough draft versus a final edit?
Perfect analogy. And they found that you can change the size of those chunks depending on what you need. Need an answer fast? Make the chunk small. Want it to sound really good? Give it some time to work on those chunks.
That's really neat. It's like you can customize the AI. But can you give me an example? I'm still trying to imagine how this would work in real life.
Okay, so let's say you're using LLaMA-Omni on your phone, like a helper. You're cooking dinner and need to set a timer, but your hands are covered in flour.
All right, I can see it now. Chaos in the kitchen. My cookbook's covered in sauce. This AI better be good.
Don't worry, LLaMA-Omni's got this. You just say, hey, LLaMA-Omni, set a timer for 20 minutes.
Okay, sounds easy enough. Does it understand me even though I'm all covered in flour?
That's where that speech encoder comes in. It figures out what you're saying, even with a little noise, and turns it into something the AI gets.
So it's listening to me and making my voice into something the AI can work with.
Exactly. Then that speech adapter simplifies things and gives it to the LLM. The LLM is the one that's really doing the thinking.
So the LLM is like the chef in my kitchen, figuring out what to do with my instructions.
Exactly. It understands what you want and then says, setting a timer for 20 minutes.
Okay, so it heard me and told me it's doing it. But how do I hear that? Is that where the music idea comes back?
Yep. While the LLM is working, that speech decoder is busy turning the words into sounds.
Like it's writing music for the vocoder to play.
You got it. And then the vocoder, that's like the instrument, takes those sounds and makes the audio you hear. So you'd hear setting a timer for 20 minutes, even over the sound of your dinner cooking.
Wow. That's like having an extra set of hands in the kitchen who understands everything I say. But I bet this isn't just for cooking, right?
No way. We're just scratching the surface here. There's so much you could do with this kind of AI. It could change everything.
Okay, you've piqued my interest. Tell me more. What else could we do with this? What does the future look like?
Think about it. People who can't see well or have trouble moving could use technology just by talking. No more messing with tiny buttons or menus. Just talk to it.
That's a really good point. It could change things for people who haven't been able to use technology easily before. It's like everyone gets a chance now.
Exactly. And imagine what it could do for education. Students could actually talk to AI tutors, ask questions, and learn at their own speed.
That's amazing. Like a personal teacher who's always there for you and can explain things in a way that makes sense to you. It could change how we learn completely.
Absolutely. And we can't forget about entertainment. Imagine stories where the characters actually talk to you. The story changes based on what you do. It would be a totally different experience.
Wow, that sounds like something out of a movie. It's incredible how this tech could blend reality and make-believe, creating these amazing and engaging experiences.
It's a really exciting time to be working in this area, that's for sure. But like with anything powerful, we got to be careful about the downsides too.
Right, got to look at both sides.
Yeah.
So what are some of the problems or ethical concerns that come with this level of AI interaction?
Well, one thing is people could misuse it. Imagine someone making fake videos or audio that sounds just like a real person. It could make it impossible to know what's real online.
That's kind of scary, like those catfish scams, but way worse.
Yeah.
It's already hard to tell what's true online. This could make it even harder.
Exactly. And there's the problem of bias. If these models are trained on data that's already biased, we could end up with AI that's unfair or discriminates against certain groups.
So it's not just about the tech itself, but about the information it learns from and the values it's taught. We need to build AI systems that are fair and treat everyone equally.
Couldn't have said it better myself. And we also have to think about jobs. As this tech gets better, some jobs that need people to talk to each other might be done by AI instead.
That's true. We have to think about that as a society. How do we get ready for a world where AI is doing more of the work? How do we make sure everyone benefits from these changes and that nobody gets left behind?
Big questions and no easy answers. But we need to talk about them now. We need to teach people new skills so they can adapt to new jobs, and we need to help people who might lose their jobs because of AI.
It's complicated, but we can't ignore it. We have to be smart about using this tech and make sure it works for everyone.
Absolutely. Finding that balance between progress and doing the right thing.
Well, I think we've given our listeners a lot to think about today. Our deep dive into LLaMA-Omni has been amazing, from the nuts and bolts of how it works to the bigger questions about AI and society.
It's been great talking about this with you and our listeners.
I've really enjoyed it too. And to everyone listening, thank you for coming along on this exploration of cutting-edge AI. We've covered a lot, but this is just the start. As AI keeps changing, we have to stay informed, get involved, and help shape the future we want. Until next time, keep those minds curious and those voices heard.